Hello everyone! In this tutorial, I will show you how to create and render abstract geometry based on Vellum simulation. Let's start. Let's create a geometry node, create a sphere, switch to polygon mode to get a uniform triangular topology. Let's increase the frequency and we can make it a little bit bigger. And let's raise it a little bit above the ground like this. So next we need to divide the geometry into several parts by topology. For this I will use the edge fracture node. Visually nothing has changed. To check it we switch on primitive piece and click on toggle visualization. Now we can see how the geometry is split. You can also check with the exploded view node that these are separate pieces. I think that will be enough. Let's increase the initial pieces. I think 14 will be enough. The most important thing here is that we have created groups that are in the cut of the geometry. That is, if we look, we have new points and original points groups. That's going to come in handy for the simulation. We can already move on to the simulation. Since it will be an inflated balloon, we can use the preset called Vellum balloon. Here we have created pressure constraint, which will preserve the volume of the geometry. Let's create a Vellum solver, and for the test, let's turn on ground collision. And we can see the geometry explode into pieces. Now we need to stitch these pieces together. Create a Vellum constraint. In this case, it doesn't matter where you put this constraint. And switch the constraint type to weld points. We immediately see that constraint appeared exactly in the cut points because it has a default constraint to closest point. That is, it automatically calculated where there is a cut point and created constraints in this place. Let's try the simulation again, and we see that the geometry does not fly apart and everything holds. Let's move on. We no longer need collision with the ground, and we will not use gravity in this setup. Now the geometry has a little bit of movement. And now we're going to put tension on the seams. To do this, let's create another Vellum constraint called distance along edge. Switch the group type to point, and just here we will use the new points group that was created in the edge fracture node. We can see that constraints are created exactly at the seams. Now we need to tension this constraint. If we now try to do a simulation, we will see that nothing has changed. Vellum distance constraint has a parameter rest length scale which stores the values of the original distance between the points. That is, if we set the value less than 1, then the points will try to collapse. If more than 1, then the points will increase the distance. Well, let's set 0.1 and we can see that now the geometry at the seams is trying to collapse. But now we don't have enough detail to see a strong stretch. To fix this, let's select Vellum cloth and set bend stiffness to 0. This way we will eliminate the bend stiffness and see that there is a lot more detail than there was before. Now I want to make the geometry even more detailed. Let's increase the frequency of the sphere. We'll set it to 100. We see that the location of the seams has changed because the topology has changed. But it doesn't matter because the new points are in the new points group and everything will work as it should. If we do a simulation now, we can see that everything is okay. I would like to add more details and add more folds on the geometry. In the Vellum cloth node in the stretch tab here, we have also rest length scale, which also stores the original distance between points, but for the whole geometry. This will give more folds and detail. Let's set the value 1.1 to increase the distance between the points. Let's see what we get in the simulation. The whole geometry gets so wrinkled in the first few frames, but then it starts to look good with more detail. Although first we'll turn off visualization and increase the frequency even more. I think 150 will be enough for the final quality. There's 225,000 points here, so yeah, I think that's enough. It's a pretty dense mesh. It'll be good for later rendering. Let's simulate a few frames. Yeah, that's okay. Let's just delete the attributes. I don't think we even need any attributes to work with here, so we can just hit delete non-selected. We'll keep the groups just in case. Let's create a file cache. I'm going to disable versions here, and I think that's enough. We can put it on the simulation. So here's what we got. The simulation looks pretty good, so let's proceed to the next step. The easiest way to add details is to create a polyextrude node. Switch divide mode to individual elements, then each primitive will be extruded as a separate element. Let's increase the distance, so we can see that each primitive is extruded. But now it's a pretty big value. Let's reduce it a little bit. And let's increase the inset a little bit. But that doesn't work in this setup. Still, I'd like to make the top edge scaled down a little bit. To do that, go to the Spine Control tab and decrease the thickness scale. I think that this result will be enough. Let's look at the frames. Yeah, overall it looks good. And let's also set the node normal to make the geometry display correct. Yes, now everything looks good and we can start rendering.